You know that diet soda you might be sipping on? Or that little packet of sweetener you stir into your coffee? We all think we're being smart, right? Cutting calories. But what if those very things are secretly hijacking your brain and actually making you hungrier? Yeah, let's dive in.
I mean, this is the million-dollar question, isn't it? For years, the logic has been, hey, no calories, no problem. But new science is showing us that our brains react in some really unexpected ways. And the answer could totally change the way you look at sweeteners forever.
And look, this isn't just another hot take or some online opinion. We're talking about a seriously powerful new study that used advanced tech to literally look inside the human brain while people were consuming these sweeteners. They were hunting for a real, definitive answer, and what they found could rewrite the entire rulebook.
So to really get why this study is such a big deal, you first have to understand the debate that's been raging for years. If you go online, you basically find two completely opposite camps, and they both sound pretty convincing.
On one side, you've got the calorie savers, and their logic is super simple. Less sugar equals fewer calories, which should mean less fat. Makes total sense on paper, right? But then you have the other side, the metabolic saboteurs, and they're pointing to all these studies where sweetener use and obesity rates seem to be climbing together, suggesting these things are somehow tricking our bodies into gaining weight. It's been a total deadlock. Well, until now.
All right, so researchers basically said, enough is enough, let's settle this. They designed a study to get a clear, undeniable look at what is really going on inside our brains when we have a sweetener.
And this was a legit study, for sure. They didn't just grab a few healthy people. They brought in 75 young adults from across the entire weight spectrum, healthy, overweight, and folks with obesity. And critically, they included both men and women, using these powerful fMRI scans to watch the brain react in real time.
The setup was just brilliant in its simplicity. On different days, each person got one of 3 drinks. One with sucralose, the main ingredient in Splenda. One with good old-fashioned sugar, and one that was just plain water. While they were drinking, scientists were watching their brains, and then they asked a simple question. So, how hungry are you right now?
Okay, and this is where things get really, really interesting. The results from those brain scans were, well, they were shocking. They might just hold the key to why so many of us struggle with cravings and weight, even when we swear we're making all the right choices.
Let's zero in on the hypothalamus. Now, this isn't just some random part of your brain. It's the ancient primal command center that controls hunger, thirst, your body's entire energy budget. It's constantly asking, do we have enough fuel? When it's calm, you feel full and satisfied. When it's active, it sends out powerful hunger alarms. So, the sugar drink, it did exactly what you'd expect. It delivered energy, and the hypothalamus just chilled out. But the sucralose, it did the complete opposite. It sent that area into overdrive, lighting up the very region of the brain that screams, I'm hungry.
And this wasn't just some abstract activity on a computer screen. No, the brain scans perfectly matched with the people were actually feeling. They straight up reported being hungrier after drinking sucralose than after the real sugar. That brain signal translated directly into a real, nagging feeling of hunger.
But here's a fascinating twist. The effect wasn't the same for everybody. The study found that 2 specific groups had a much stronger brain response. Women, for one, showed a more intense reaction to sucralose than men did, and people with obesity responded way more strongly compared to those at a healthy weight. This suggests that some of us are just far more vulnerable to this hunger hijacking effect.
So we know what happened, but the real mystery is why. Why on earth would a zero-calorie sweetener make your brain's hunger center go completely haywire? Well, the answer lies in this really cool neurological idea.
It's called a prediction error. You see, for millions of years, our brains have been hardwired with the very simple life-saving equation. Sweet taste equals energy is coming. It's a survival instinct. A prediction error is what happens when the brain gets that sweet signal, but then the expected energy, the calories, they never show up.
The researchers had the perfect analogy for this. Imagine you get that notification on your phone. You know the one, the package you've been waiting for has just been delivered. You get that little buzz of excitement, right? That anticipation?
But then you go to the front door, and there's nothing there. The promise was made, but the delivery completely failed. That is exactly what sucralose does to your brain. Your tongue tells your brain, get ready, energy's on the way, and then crickets. No glucose arrives.
And your brain doesn't just go, oh, okay, never mind. No way, it does the opposite. It fires up those hunger circuits even more, basically screaming, hey, what gives? Where are the calories you promised me? We need to find some, like now.
And this just brilliantly explains the mechanism that can drive you to overeat later, completely canceling out any calories you thought you were saving.
Now, this whole prediction error thing, it's not just a quick little moment of confusion in your brain. When we connect the dots with other research, we can see how this one faulty signal can kick off a long-term metabolic chain reaction all throughout the body.
And you can just watch the dominoes fall here, creating this whole metabolic mess. It starts with that immediate prediction error in the brain, but it doesn't stop there. Other studies show that, over a few weeks, sucralose can start messing with your gut microbiome. And then, get this, another study found that after just 10 weeks of regular use, people's bodies had to work way harder, pumping out more insulin to process the exact same amount of sugar. That is a direct path to insulin resistance. So yeah, one faulty brain signal can cascade into major problems for the whole system.
Okay, so this all sounds pretty alarming, I know. But the point here isn't to demonize all sweeteners. The goal is to be smarter about them, to actually understand what's happening inside our bodies so we can make better, more informed choices.
So here's the bottom line. The big takeaway from all of this: sweetness without calories isn't free. It always comes with a potential metabolic cost because you're constantly tricking your body's ancient, hardwired survival programming. So what should you actually use? Well, based on the research we have now, some sweeteners definitely look better than others. Allulose is highly recommended because it might actually help with blood sugar control. Stevia and monk fruit are also really good alternatives that don't seem to cause that same dramatic effect. And what about sweeteners like sucralose and aspartame? Well, this research strongly suggests they should probably be in the use in moderation category, with a full understanding of what they might be doing to your brain's hunger signals.
And that leaves us with one last, pretty powerful question to think about. If the sweetness that we all thought was a free pass actually comes at a price, we really have to ask ourselves, what is the real cost, and is it one we're willing to pay?